Welcome to Chiropractic Science, where you get to hear interviews with leading chiropractic researchers from around the world. Hear about chiropractic research from the authors in plain English, not through the media nor a middleman. My name is Dr. Dean Smith, and I am the host of Chiropractic Science. I am an associate clinical professor in the Department of Kinesiology and Health at Miami University, and I'm also a chiropractor in Eaton, Ohio. My research interests relate to understanding how chiropractic affects motor control and human performance. Today, I have the privilege of interviewing Dr. Martha Funabashi. But before we get into the interview, I wanted to thank all of you who have subscribed to Chiropractic Science, and I'm especially appreciative to all of you who have contributed 5-star reviews on iTunes. iTunes really helps others find out about chiropractic science. So if you like the show, please take a second and write a review. It will support chiropractors everywhere. I look forward to sharing your iTunes review in a future podcast. Please consider making a contribution to Chiropractic Science to keep these podcasts going. You can do so on our website either by making a donation or by purchasing the evidence-based patient education slides presentation at chiropracticscience.com. We're also on social media, including Facebook and Instagram, so please connect with us there. I'd like to share a review about the Chiropractic Science Patient Education Slides presentation from Dr. John Taylor at DUville College. He says, "We just received our copy of the excellent slide presentation from chiropracticscience.com. We are displaying these in the patient reception area of our college campus Chiropractic Healthcare Center here at DUville College. The faculty, staff, students, interns, and patients are all very impressed with the quality of the slides and the content of the messages. Each slide addresses a different message derived directly from the best research publications by our profession's most credible researchers. These messages really hit home with patients based on comments such as, 'I did not know that chiropractic was helpful for children,' and 'So chiropractic is great for back pain and pregnancy too?' This is the kind of evidence-informed marketing we encourage our students to use when they establish their practices. No hype, no exaggerated claims, just solid information. Thank you for this contribution to our profession." Well, thank you, Dr. John Taylor, for sharing this message with us. All right, on to the podcast. Well, let's get on to the interview with Dr. Martha Funabashi. Martha Funabashi is a PhD currently working as a clinical research scientist at CMCC. She is also a Carl Fellow and the co-lead study coordinator of SafetyNet, an international and multidisciplinary research team to support patient safety among spinal manipulative therapy providers. Martha has a bachelor's degree in physiotherapy and a master's degree in neuroscience from the University of Sao Paulo, Brazil. She completed her PhD in rehabilitation sciences at the University of Alberta under the supervision of Dr. Koch Chuck, and her postdoctoral fellowship also at the University of Alberta with Dr. Sunita Vora. Martha's research interests and passions are on the SMT's biomechanics, underlying mechanisms, force time characterization, and safety aspects. So SMT, just for everybody, is spinal manipulative therapy. Martha has 26 peer-reviewed scientific journal publications, over 40 conference presentations, and is on the editorial boards for peer-reviewed journals such as Chiropractic and Manual Therapies. Martha has won research prizes, including the New Investigator Award at the World Federation of Chiropractic Conference in 2017, and works in collaboration with emerging and well-known researchers from around the world. Dr. Funabashi, thanks so much for coming on to the Chiropractic Science podcast.
Oh, thank you very much for having me. It is my pleasure to be here today.
Great. Well, I always like to ask how you became interested in doing what you do. So how did you become interested in becoming a physical therapist?
Yes, right. So that was when I was about on grade 8, maybe. And at the time, my brother was finishing high school and he had to choose a career for himself. So my parents bought a magazine that described all different professions to help him to make a decision. And then one day I borrowed, let's say that way, his magazine and started reading it. And at that point, I knew I wanted to be in a healthcare related profession. And growing up, I was always involved with some kind of physical activity. So it was either dancing or sports. So swimming, volleyball, soccer. And I think one thing led to the other. And when I read the physiotherapy description, it sparkled. I knew that was exactly what I wanted to do. And so I did.
That's great. So you became a physical therapist, and then how did you get from Brazil to doing research with Dr. Koch Chuck at the University of Alberta?
Yeah, so it always started, I think, back during my physiotherapy degree. And I was very fortunate that I was able to get into the physio program at a public university in Brazil that is very evidence-based and has a strong research program. So during my entire degree, I was exposed and somehow involved with research already. And then during my final year of the physio degree, so during placements, I noticed that we were getting a lot of referrals of patients with balance disorders, which was a relatively new population for that specific hospital. So I conducted a research project, and that was a requirement to graduate. But during that project, I developed an assessment protocol for patients with balance disorders. And that protocol was actually implemented in the physio service in that hospital. So I was really happy to see that with research, I was able to help both the physios and the patients. And that kind of inspired me to keep doing further research. So that's how I got into my master's degree. And how I moved into Edmonton and got involved with Greg was, it's actually a funny story. After I finished my physio degree, I was doing my master's, and it was also in balance disorders. But at the same time, I was also practicing in an orthopedic rehabilitation center. And I was also getting some additional manual therapy training in osteopathic techniques. So that's how I first got in contact with spinal manipulation, got more information about spinal mobilization. And with all those things happening at the same time, I started applying all those new techniques of manual therapy that I was learning to my patients. And then there was one specific patient that I was treating him for a while. And he was actually a soccer player that played professionally, but he had to step down for a while because of low back pain. And I was treating him for a while, and he was improving, but very slowly. So then I tried a few different things that I had just learned, some manipulations, some mobilizations, some additional exercises. And he was one of those patients that, one, responded really well to manual therapy, and he improved very quickly. And two, was very excited about it. And he was like, oh my God, this is a miracle. You have magical hands. This is amazing. How does it work? What does it do to me? And is it safe? And since I was already doing my master's at the time, I was very aware of evidence-based information. And so it bothered me that I didn't have evidence to back me up in my response. So at the time, I mumbled something to him, and it was fine. But those questions stick with me in the back of my mind. And then some time passed by, and then I had a friend who also did her physio degree with me. Her name is Larissa, and she came for a visit. And at that time, she was doing her master's degree at the U of A. So during her visit, she was telling me about U of A, showing me pictures, telling me about her experience, her research. And then I was like, wow, that's very cool. I want to experience that too. And then at the time, I knew that I wanted to change topics. And for my PhD, I wanted to move from balance disorders into manual therapy. So when she left, I went online at the U of A website, and I found Greg. And it was funny because when I found him and his profile, I was super excited, but I also got super scared because his profile page actually said that he's interested in technology, robotics, and biomechanics. And I was like, okay, I know nothing about that. But I think I was so excited that I found him that I didn't care. I wrote him anyways. I wrote him an email asking about the PhD program. And then we had a few conversations, and finally he said yes. And then off I went to Edmonton.
Well, that is so cool. I really like the experience. And I just have to say, don't you love it when patients say you have magical hands?
I know, I love it. I feel so important.
So, do you still practice as a physical therapist today?
No, unfortunately, no. And I do miss it. So I do miss this interaction with patients and helping patients out. But for now, I'm just 100% dedicated to research.
Gotcha, for sure. Well, we definitely need your research, and we love all the articles that you've been putting out here. So let's get into some of those articles and try to get into your head of why you did them, what we've learned from these studies, and how we can go forward with the science of the biomechanics and safety of spinal manipulation. So first, if we could, I'd like you to tell us about the safety net program. In particular, there's a paper that might help us out to get into that. It's called Safety Net: Community-Based Patient Safety Initiatives, Development and Application of a Patient Safety and Quality Improvement Survey. And I believe that came from JCCA. So could you give us an overview of that study, and more broadly, what is Safety Net and what are you up to these days with Safety Net?
Absolutely. So Safety Net is actually a team of investigators who originally got together to promote and support a patient safety culture among spinal manipulation providers, and specifically chiropractors and physiotherapists. And this program involved 4 different projects. So project 1 was a qualitative study exploring the patient safety culture of spinal manipulation on patients and providers. Project 2 was about health law and patient safety, again, specifically for spinal manipulation. And then Project 3 was the community-based active surveillance reporting and learning system study. And Project 4 was the basic science investigation looking at the forces during spinal manipulation. And this is how I first got involved with Safety Net, as my PhD was part of that project. But this article that we are talking about now is specifically from the Project 3, the Active Surveillance Reporting and Learning System, which I was involved during my postdoctoral fellowship with Dr. Sunita Vora. And this paper describes the survey developed to assess the culture or the attitudes and opinions of spinal manipulation providers towards patient safety. So what we did in this paper was we did a literature review and found a few different surveys to do that. And among those was the AHRQ, so the Agency for Healthcare Research and Quality. And they had a survey that they used to assess patient safety culture in medical offices. So we adapted that survey to be more applicable, to be tailored to spinal manipulation providers in terms of language and other relevant topics, and recirculated that survey to chiropractors and physiotherapists from 4 different Canadian provinces. And what we found was that the Canadian chiropractors and physiotherapists had pretty good scores, meaning that people who responded to the survey perceived their clinical environment generally that it generally has a positive attitude towards patient safety. So that was really encouraging. And the next step of it is what we are the data that we are analyzing now. So the next step after assessing the culture is actually assessing performance. So with the safety net bigger study, so the actual active surveillance reporting system, we recorded pretty much symptom change before treatment was provided, and a treatment including spinal manipulation, immediately after, and 5 to 7 days after the treatment. So we have that immediately post, and a short-term follow-up. And we could follow how the symptom changed, and if the symptom stayed the same, if it improved, if it got worse, and if there were new symptoms. And that's the data that we are analyzing right now. And hopefully we'll have some interesting results very, very soon.
Oh, that's terrific. About how many providers did you have in that study?
Provider-wise, I think it was about 75. And then each provider, if it was a chiropractor, we asked them to collect data from about 100 patients. And then if it was a physiotherapist, we asked them to collect data from 50 patients, just because physios sometimes don't apply as many manual therapy as chiropractors. And in terms of patients, I think we collected data from almost 4,000 patients.
Wow.
And complete data sets, I think it will be about 2,000 to 3,000 data sets. So it will be very interesting. I'm very excited about that data.
Yeah, for sure. Well, we definitely look forward to that coming out, and we'll keep an eye out for that for sure. Mm-hmm. Great. Anything else that you'd like to say about the safety net?
I think that sometimes one message that might not get across with these studies is that the way that the investigators in the safety net team, how they see patient safety in this kind of research, is that a lot of people, I think they get scared and afraid when we say that we are looking at patient safety, adverse events, and they just put their shields up and don't want to listen about it. But the way that we see it is that we see it as a learning opportunity. So instead of blaming and shaming and finding who is responsible for this and pointing fingers, we are looking on the other spectrum. We are looking at it in a process way. So what can we do to the process to prevent that from happening again? Or how can we learn from what happened and prevent it from happening again? Make changes in the system to prevent it in the future. So for example, when diesel cars came out, how many people got, even though they knew their car was diesel or gas fueled, how many people didn't mix up and put diesel in a gas car or gas in a diesel car? And then, so since we know that humans do make mistakes, and sometimes we are tired, we are stressed, and we can't control for that. So why not change something in the system so to prevent that? So what happened now is that the nozzle for the diesel and the gas fuels are different, and one won't fit the other. So that's one example of a process change that can happen to prevent an undesired outcome. So that's how we see that we can learn from things, learn from the data, and do something helpful to prevent things from happening again.
Yeah, great description. I really like the idea of finding out about prevention. I mean, I'm just trying to think about patients that I see. If I had some data to suggest that a particular patient may not respond as well to a certain kind of technique, for example, then, I could use that as part of evidence-based practice to figure out what, how I want to approach that patient, maybe a little bit different based upon the kind of data that you'll be generating. So I look forward to that. I think it's great in terms of helping to prevent things. And also, when I look at the literature currently with manual-based care, it seems that the studies are suggesting a pretty good safety profile. So I'm not sure what people are really worried about necessarily.
Exactly.
Yeah, if we had data to suggest, hey, that this is significantly safer, I mean, I don't know what the results are going to suggest, but if it came out that way, then that would be nice to show, right?
Absolutely. Absolutely. And another thing is that if you are seeing a patient that is not presenting the outcomes that you're expecting, maybe another provider around the corner is seeing the same thing, and another provider on the other block is seeing the same thing. And if we just could get all these data together, we could get a better understanding of what the characteristics of those patients are, so we can better understand what are the patients that might or might not respond to in the way that we expect them to respond, right?
Yeah. Yeah, I really like that, talking about responders. And I know some of your work has dealt with that. So
Absolutely.
awesome. So, well, let's get into, if you don't mind, let's get into some of those studies then, talking about the biomechanics of spinal manipulation. And the first paper that I'd like to bring up is about tissue loading created during spinal manipulation in comparison to loading created by passive spinal movements. And before we get into describing all the things that were done in this particular paper, maybe we can just start with a basic foundation of what are some of the terms that we use when we're talking about the biomechanics of spinal manipulation. I know when I look in various papers, I see terms like preload and mean load, peak force, thrust phase. Could we just spend a little bit of time and go through some of those words and what's actually happening mechanically when we adjust or manipulate people?
Absolutely. So when you think about the graph that it's usually showed when we are talking about force and force applied during a manipulation over time, it starts with the application of a force, which is represented by a line in the graph going up. And that line represents the force that the provider is applying to the patient when trying to get into that end range, which we call it the preload phase. And that line plateaus when we get to that end range. And then it increases rapidly, which corresponds to the application of the thrust force or the actual adjustment, with the peak force or total peak force being the maximum force that was applied during that thrust. And then that line decreases rapidly again right after the thrust, corresponding to when the provider is releasing the hand from the patient. And then that entire cycle of applying and releasing the thrust forces rapidly is what we call the thrust phase. And then the mean load would be an average number, so the mathematical average of the amount of force that was applied during the whole manipulation, so including preload and thrust phase. So I think those are a brief explanation of those terms.
Yeah, absolutely. That's great. And I appreciate you going through that. So now maybe we can make some sense out of this paper on tissue loading. Can you describe what you did in this paper?
Absolutely. So in this study, we got cadaveric porcine specimens, so cadaveric pigs, and they were fresh cadavers, so the muscles were still in a condition that was they weren't in rigor mortis yet. So we drilled bone pins into L3 and L4 vertebral bodies, and we attached sensors. And we had a camera that could track those sensors. So then we applied a spinal manipulation on the back of the pig. And with those sensors, we could track and record the exact vertebral movement that occurred in those two vertebrae during the spinal manipulation. So then after that, we removed the spine from this pig, from the pig. We dissected it, we potted it, and we attached it to a load cell, which was attached to a robot. And then we transformed the vertebral movement that was recording during the spinal manipulation into robotic trajectories, meaning that the robot now can replicate the exact same movements that occurred during the manipulation, but now in a controlled environment. And besides the manipulation, we also applied passive movements of flexion, extension, and axial rotation. And the idea was to compare the forces that was experienced by the spinal structures during all these movements, and to give a context. So because it's great that we can measure the forces during manipulation, but if we don't have anything to compare to, it's hard to make it sense if it is a high force, a low force, if it is normal, or what is it. So we compared it with the forces experienced with passive movements, and what we found was that overall the forces experienced during a manipulation were comparable to, they were not that different from the ones experienced during passive movements, with a few exceptions, which, if we think about it, it makes sense, because there has to be something about the manipulation that makes the manipulation unique. Otherwise, our patients would get better with passive movements, right? So this study was the first study to measure and to actually show this, that the forces are comparable, but at the same time, there are some unique things about the manipulation that do not happen during passive movements.
Great. What were the key differences then between the passive and the spinal manipulation?
Mm-hmm. It was there was one specific force in the ligament, so the supra and interspinous ligaments. They had one specific force that was significantly greater during manipulation compared to passive movements. And for the facet joints, capsules, and ligamentum flavum, they had two forces that were were significantly greater during manipulation compared to passive movements. So when the specimen was intact and during and the forces experienced by the intervertebral disc, they were all comparable. It was just in the ligaments and in the facet joints that there was a significant difference.
Interesting. And did you measure any neurophysiological changes, like in muscles or coming from the facet joint capsules or anything like that? Or was it just the mechanical aspects?
Unfortunately, no. So we measured only the mechanics, only the forces, but combining both is something that it's in our plans for sure for future studies.
Yeah, I've got all sorts of hypotheses now in my head about what gets stimulated and muscle spindles and capsular receptors and all sorts of stuff. So that's great.
Absolutely. And we should talk because I have a few ideas as well. So
all right, good stuff. So what do you think might be some differences between a robot manipulation and a clinician-generated manipulation? Let's say a chiropractor or a PT who does this. I'm just curious.
Mm-hmm. To my knowledge, there is only one robot that can apply a manual therapy for now, the one from Martin de Carro's lab, and it only applies a posterior to anterior manual therapy, so either a P to A thrust or a P to A mobilization. But then on the other hand, humans can apply all different techniques, which moves the spine in all different planes and in all different ways, creating different loads, right? So, so there is quite a, so I think humans can apply a more variable, they have more options of techniques, but at the same time, they also have more variability, both within and between providers and techniques, which is great because they can adapt as they see the patient, but also makes the investigation of human applied manipulation a little bit more difficult, because when we are investigating the mechanisms of manipulation or how manipulation works, we want to fully understand what is happening during the manipulation. So, for example, just like we know that a specific eccentric exercise will act on a muscle by contracting it this way, and a concentric exercise will act by contracting the muscle in that way, we want to understand what happens if we use this force versus that force, or this speed versus that speed. And similar to exercise, where eccentric contractions work better for some conditions and concentric contractions work better for other conditions, is there a condition that would benefit more from this force over that force? Or so that's why we use the robots in research to reduce that within and between provider variability, to have a more standardized spinal manipulation application, so that we can fully understand what each component and each characteristic of the manipulation does, how it affects the body, and how we can best use it. So who would be the patient who would benefit the most from this or that force, or this or that speed, or any other characteristic of the manipulation.
Yeah, I love it. I love it. It's basically breaking down the experience, and my hope is that based upon your research, we can teach practitioners in a shorter period of time than what it's taken me 20 years to do in practice. And I still continue to learn every day, how to adjust people. It seems like that variability is definitely key. And there's something we pick up on as practitioners for sure on a day-to-day basis or visit-to-visit basis. And I look forward to more and more of your research that starts to get at what are the key variables to study, and how do we best know how to deliver the appropriate care, and it blends very nicely with the safety net as well. So I see all of these things as being just a terrific way to answer some of these questions. So thanks again for doing what you do.
Exactly. And that's what we are hoping we can do, right? We're working towards that. Yes.
Absolutely. Well, I've got another paper that I'd like you to talk about too. And this is a paper, Does the Application Site of Spinal Manipulative Therapy Alter Spinal Tissue Loading? Could you guide us through this paper?
Mm-hmm. So yeah, and so the rationale for that paper was that we know that clinical palpation is not very accurate in identifying the levels, the spinal levels. So the question was, what if our palpation goes wrong and we are at the wrong level to apply, and we apply the manipulation at that wrong level? Like, what would happen? So what we did was we used pretty much the same setup where we had the porcine pig, we had the bone pins with the sensors, and what we did was that we applied the manipulation at different locations of the spine. So we applied it at L2, L3 facet joint, and then L3 transverse process, L3, L4 facet joint, and L4 transverse process, so adjacent spinal levels. And we also applied the manipulation in between those spots, so in between those facet joints and in between those transverse processes, because that can happen as well, right? And we process it the same way. We removed the spine, we potted it, we attach it to a load cell, we got the robot to replicate the spinal manipulation applied at each different application site, and recorded the forces during those manipulations. And what we saw was that the spinal tissues, the spinal structures, the forces that they that they experienced during a manipulation that was in adjacent levels. So, for example, a manipulation that was applied to L3, the forces had an opposite direction to the forces experienced when the manipulation was applied at L4, which makes sense because we are applying the movement in different levels, which create relatively opposite movement. So it makes sense that the forces will also be at opposite directions. And then when we apply the manipulation in between those landmarks, in between facet joints and in between transverse process, the forces experienced by the spinal structures were significantly smaller, which also makes sense because we are not targeting one specific structure, so the forces get dissipated and they're not as high as the other ones.
Gotcha. So, yeah, now this coupled with some of the knowledge that, when we look at, for example, what am I thinking about? I'm thinking about studies that have done some acoustic recordings over where people manipulate and found that where we think we're manipulating isn't even at the right place. So then I think about this and I think, okay, so one level away and things are significantly different in terms of what's happening mechanically. So wow, what a great degree of variability here. I mean, just clinically, like we think we are maybe getting specific, but then how does the specificity relate? It seems to relate pretty good. I mean, in terms of mechanically what's going on. I don't know what to think about all this, but there's a quote. Maybe this is the way to get to it. There's a quote from the article. You say, although the effective SMT or manipulation application site on meaningful patient outcomes has yet to be described in a human clinical trial, this work provides justification for pursuing this line of questioning. So have you given thought as to how you'd go about doing that?
I have, but it probably won't get approved by the ethics committee. No, I'm kidding.
Now I'm intrigued.
And I think there are a few ways to look into this. And here at CMCC and with some collaborators, we are now starting to investigate the combination of manipulation characteristics with clinical outcomes. And when it comes to application side specifically, it's a little bit trickier because as we were talking about, palpation is not very accurate to identify the spinal levels. We are not applying the manipulation where we think we are. And depending also on your hand contact, you might be already applying the force into more than one level of the spine. And so even before that, I think we actually need to be sure that there is no issues with applying the manipulation at a level that may not require an adjustment. So that's why I think we need some more work before we start looking into this clinically with our patients. So I think this is still a working process, and this line of research is only starting now, and so there's a lot of work to do.
Absolutely. So keep busy.
Yes, I will.
Now, you found overall that intervertebral disc structures, as well as other structures, experience greater forces than some of the other spine structures. How do the forces generated during manipulation within the disc compare to, let's say, forces of activities of daily living, such as bending or jumping or walking or whatever people do?
Mm-hmm. This is a great question and very hard to answer because there's no one paper that makes this direct comparison on the same specimen. So that means that to answer that question, we are now comparing forces measured by different studies using different instruments and tools to measure that force, that used different samples in different conditions. So some papers use humans, some papers use animals, some papers use cadaveric models, and some papers use living samples. And all this will influence on the results and limit our interpretation when we compare these studies. But having said that, and with all those limitations in mind, during our experiments with the cadaveric pigs, we measured that the forces experienced by the intervertebral disc structures were about 30 newtons on average, sometimes more, sometimes less, but on average was about that magnitude. And that 30 newtons is actually comparable to the forces in the disc measured in different studies. For example, in a study that used a computer model during and estimated the forces in the disc during walking and climbing stairs, and they reported the forces in the disc to be about 30 to 40 newtons. So they are somewhat comparable and somewhat similar. And even though we saw that most forces go to the intervertebral disc structures, in the previous paper that we were discussing, we compared those forces to the ones measured during passive movements of the spine, and the intervertebral disc did not show significant differences. So it seems that the forces that go to the intervertebral disc structures are comparable to everyday movement forces, but given all the limitation that we just talked about when comparing different studies, we cannot say that for sure, at least not yet, not until we have one direct comparison on the same specimen.
Yeah, for sure. And I'm just wondering that I'm guessing that the plane in which the forces are applied to the disc are, my guess would be a little bit different than many daily activities as well.
Yes, I would agree. I would agree completely, because during manipulation, we might move the spine in a depending on the technique, right? If you're using a side posture, you might apply more rotation than you would normally do in an active, in a daily movement. So you're absolutely right.
I'm just curious, now that we've talked about the disc and some of these other structures, if we can relate it back to the safety net study, just so I can get a little bit of an understanding of what to expect when that comes out. In that study where you were collecting data from patients about their experiences pre and post care, did you ask questions about well, I guess you wouldn't ask necessarily about their discs, but I'm sure you asked about, subsequent back pain, leg pain, that type of thing.
Mm-hmm, yes, we did. So we had a list of symptoms that usually symptoms that patients do report. So we had pain, stiffness, weakness, and we did track what their symptoms were before and the severity of their symptoms before and then after as well. And you're right, we couldn't, and they wouldn't know specifically where their pain is, but they could tell us if it got worse, if it got expanded to another region of the body, for example, from low back pain and it started to the leg. They had the opportunity to tell us that as well.
Gotcha. So from these studies that we've just talked about, and I guess just drawing on perhaps other studies that you've done as well, can we start to offer clinicians advice on how or what to adjust or manipulate based upon this biomechanical research?
I think it's a little bit too soon for that, because even though we did find differences in forces depending on the location in which manipulation was applied or depending on the technique that was applied, we still don't know what these forces mean clinically and what clinical effect it might have in those spinal structures. So to make a clinical recommendation based on these results, I think we are not there yet. I think we need more more evidence first.
Absolutely. Absolutely. Well, I do want to ask another question here about, I guess research in general. I think you have a very interesting outlook from, the various places that you've not only gone to school, but done research, and now being at CMCC and getting exposed to, I'm sure, tons of other researchers and their work. What do you see as some important research topics that maybe we should be pursuing at this point? And you could talk about your own research, where you might be headed, or where you think the profession needs to go. And then perhaps a follow-up would be, how do we increase our research capacity?
So first question, the important research topics, I think pretty much everything. And as you said, since I started here at CMCC, I am more in contact with different areas of research. And every time I talk to one of the researchers, and they tell me about their research area and their research interests, I'm like, oh my God, this is so interesting and so important. And I keep telling this to everybody, and I kind of feel repetitive, but that's how I actually feel. And everything is really important, from basic science until epidemiology, and implementation and all the clinical studies. I think everything is very interesting, very important, and very needed. I think the thing is that we need more evidence in what we do. And so, and I know there's great research coming out, and we can see that more and more collaboration are happening between different research areas. And I think that's very, very exciting. So the paths that I'm going towards here at CMCC is that I'm still continuing on the basic science research and trying to connect that force measurement and relate to how safe manipulation is, and also going to the clinical side, trying to connect the manipulation characteristics with clinical outcomes, as well as looking into safety, patient safety culture, and implementing the reporting system, implementing a learning system so that we can have that full patient safety experience and potentially enhance and improve the culture here. So instead of being scared of reporting an incident, learning from it and making changes in the process, so in the long term we can deliver a safer care, and exposing also students to that type of research so they get comfortable about talking about patient safety, about incidents, about adverse events, and have them reflect on them and learn from them so they can apply them to their clinics when they are out there having their own offices.
Yeah, very good. I really like it, and I think exactly the same way you do. I think everything really needs to keep being done and explore more areas. And there's no area that doesn't need to be worked on, essentially.
Exactly.
It all needs to be worked on. So thanks for talking about that. Do you have any thoughts on how to increase our research capacity at this point?
Oh, right. Yes. I think it can start with exposing students to research earlier in their program. And that's what happened with me, right? And providing them with good mentorship. And when I say mentorship, I'm not only referring to experienced and well-established researchers, but also mentorship with their peers and that they are in similar stages of their career. So peer mentoring, and have them learn from each other, support each other, and inspire each other, which is something I learned with Carl. I think that we got a very good group together, and that's what we've been doing. So we've been learning from each other a lot and supporting each other whenever we are going through hard phases or good phases, or and just inspiring each other. And I think that motivates us to keep going, keep working hard, and keep producing and keep, yeah.
Yeah, very good. Very good. I love it. One last question, and this is a question I ask everybody who comes on the podcast. One of my favorite questions, because the podcast, one of the purposes is try to get more people into research. So if you could you offer any advice to aspiring chiropractors or students or PTs, for that matter, who wish to become scientists and researchers and get into this adventure? Could you give them some advice?
Yes, I think I would say, if you are interested, if you want to do research, just do it. I mean, I love it. I have a lot of fun doing it. So if you want to become one of us, do it. I mean, of course, find a topic that you love. Then it is important to get some training to make sure that you're thinking right and following the right steps for a good research. And then having good mentors and collaborators that can guide and support you through the way. I think it helps a lot as well. But then after that, it's just get creative, keep asking questions, and go for it.
Yeah, well stated. Everybody that I've talked to who's a researcher, they just love what they do. It's like clinicians in practice. They, most of them love what they do, and why not add something else to it? So add some research.
Exactly.
And then you can love two things.
Exactly. And just one final note, like for your listeners, whoever clinicians who are interested in getting involved with research, if they want to be part of it, they can send me an email, and whenever I have some studies that I need to recruit providers or need providers to collect data from their patients, I can send them the information, and they can be part of it or not, depending on their interest, of course.
Yeah, for sure. And do you want to give your email out now, or just give it to me later and I can put it on the website?
Yeah. Yes. It's Funabashi at cmcc.ca, and I'll do both. I'll send you right after, so you can post it online as well.
Yeah, perfect. Martha, thanks for coming on the podcast. This was a blast. I learned a lot, and it's always, in some sense validating just hearing what other people are doing, the research, and thinking about all the interesting questions that come about through the research process and the hypotheses that we all develop. And so very cool. I really enjoyed it. Thank you.
No, yes. Thank you very much, Dean. And thank you for doing this podcast. I think it's really important and really good work. And it's a really good channel for us researchers to be able to communicate our work to the clinicians out there. So thank you very much.
Thank you.